and welcome to Grade 5 Math. This is Mr. Boolsen or Mr. Guru. You have to decide. I don't know. Anyways, it's nice and early on this beautiful day on Saturday, and I'm gonna head to London today actually, so I'm recording this really early in the morning. But other than the fact that I'm still sleepy and still have a wet head from showering, this should be a great time to do a video because I can hear birds chirping and stuff happening outside. Anyways, yeah, I'll just get into it. We're continuing. Yesterday your video was on improper fractions. And well, actually, I guess it was Friday. Would be improper fractions, mixed numbers, but it was just the intro. Today we are just going a little bit further and just understanding it a little bit more. So, yeah, I just wanted to start off by drawing a nice circle. You know me, I draw circles for a living, basically. There's a circle, and you take a look. Now, I know you're probably saying, Sean, you should close that lid. I should, but I'm not going to. Okay, so if I see this and just draw this in here, what fraction is this? Well, we would just say that that's 1/2. But now, wait for it, kids. Don't get overwhelmed. If we do this, what are we talking about here? What are we talking about? Well, we're talking about a hole. The whole shape is shaded in, right? The whole shape is shaded in. Everything. But we're also talking about, at the same time, 2 halves, right? There's still 2 halves, and they're both shaded in. So there's 2 halves for every hole. So that's correct, right? And 2 halves means you have 2 out of 2 pieces, so that means you have 1 hole. But yeah, we can also say that there are 2 halves. Now this is important because we need to be able to use this later. So if I ask you, for example, how many halves are in 3 of these lovely circles? So if I said, how many in 3, how would you figure that out? Well, we know that for every 1/2, right, when we were doing 1/2, that there are 2, or 1 whole. For every whole, we'll call them a pi. For every whole pi, there are 2 halves. So if I had 3 pies, how many halves would I have? Well, for every 1 pi, I would have to times it by 2, because there's 1 to 2, 2 halves, and that would give us our answer of total number of halves, which would be 6. And I can show you this quickly, just for your, I'll do it in smaller shapes, but you know, there you go, half, 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 and right, if we shade it all in, we will get a total of 1, 2, 3, 4, 5, 6. So we just said we times it by 3, right, or 2. So each there were 1, 2, 3 shapes, but we split them all in 2, and so we multiplied them in 2 because that will give us a total of 6 halves, right? 6 pieces of 2. So there we go. That is that. Now, if we wanted to say, if I ask you a really tricky one, like how many do you think are going to be in 4 halves? Well, now I know that you're a math pro, and you could very likely understand. So you say 4, how many? Well, you just multiply that by 2, and that'll give you your amount of halves, right? So that'll be 8, and it's 8 over 2, 8 halves. So I hope that makes sense. Yeah, I could have shown you that again, but I think you'll understand. So now, just to see that you guys are all following and awake, we're gonna see about fourths. So what's a fourth? If I say we have fourths, that means we're dividing it up like this, right? Into 4 equal pieces. And if we have 4 fourths, right? If this is 1/4, that's 2, 3, and this is 4 fourths, right? There are 4 of them all filled in, 4 fourths, and that equals 1 whole, right? But there are still 4 fourths or 4 quarters to make up the 1 whole. And so yeah, we can see that. And then now if I asked you what if there were 2 of these nice beautiful shapes, 2 pizza pies, what would we be dealing with? Well, so if there's 4 in 1, then we just do know that there's 4 in 2, so we just times it by 2, right? The other way you could do it, right? If I asked you what 4 was, you could technically do it like this: 4 plus 4. If there's 2, you say, oh, that equals 8. But if I ask you what maybe 5 of them is, then you rather just times it because it's gonna take you too long. So that would give you 20, right? So if there were 5 of these circles pies, you'd have 20 pieces, 20 quarters, right? 20 fourths. Yeah, so that should be fairly straightforward, right? And what are these when we have numbers like this? What would we be calling this? This is an irregular fraction, right? An improper fraction. So, because it has the right, it has the numerator is bigger than the denominator. So yeah, that's the most important thing. We know that it is an improper fraction, so we're still dealing with improper fractions. But we're going to use this today, and now watch, we're getting more and more tricky here. So if I draw these shapes for you here, 1 circle, 2 circles, 3 circles, 4 circles, and a half, and I want to get an improper. I want to know how many halves. So actually, yeah, so how many halves do we have in total? But you'll just have to bear with me while I quickly shade in all our shapes. Okay, so we could count them right here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 over 2, obviously. Or the other way we could do it is we could say, well, these ones are all whole pieces, right? They're all whole pieces. And so there's 4 whole pieces. And we know that we have to multiply that by 2. And that's going to equal 8, right? 8 over 2, because we're dealing with halves. And then we can just add this extra one, right? That one's just an extra 1 over 2. And then we get 9 over 2, correct? So that's a faster, different way. If you aren't given the actual pictures to figure it out, you just multiply the amount of whole ones, and then you add the last piece. So yeah, that's the best way to do it, because we learned that if you have 4 pieces, full pieces, and they're all divided in half, you can just multiply 4 by 2, or if it was 3, you'd multiply 3 by 2, if it was 5, and if they were in quarters, right, we would do it a bit differently, of course. So if they were in quarters, what would we do? Well, instead, first off, have a whole different thing. So if these were in quarters instead, we would have to say, okay, well, there are still 4. We still have 4, but now they're all divided into fourths. So we times it by 4 instead, right? Because there's now, for every 1 whole piece, there's 4 small pieces. So it's times 4. There's 4 groups of 4. And that's going to give you a good old 16. And then we have how many extra, and that'll be over 4. And then we have how many extra? 1, 2. So then we just plus 2 over 4, and that gives us 18 over 4. So yeah, this is a way to add it together. And now what is this again? This one here and this one, what are these? These are improper fractions. So ultimately, we're probably going to want to change that. Now I can show you it one more time just with the math. Say I was given a whole number. So instead of giving the shape, I was just given 5 and a half. So what do we know we have to do here? Well, we know we're looking for the halves of, we're trying to turn this into an improper fraction, right? To get it all in halves. So what we know is that the 5s, that for every 5 there were 2 halves. So we go 5 times 2 equals 10. Yes, good job. And then we're going to add, right? Because that's just for this part. Just for that part. That's 5. 5 times 2. So that we're making the wholes into halves, basically. So this is the portion that's for the wholes. And this is the extra. This is the extra part in here. So we have 5 wholes, so 5 circles that are fully shaded in, right? These ones are fully shaded in. And then we have 1 circle, so this is times 5. And then we have 1 circle that is half shaded in. So times 1. So yeah, so we got this, and we have 10 over 2, and then we have this last bit remaining, which is plus 1 over 2, and that gives us 11 over 2. So that's our improper fraction that we derived from a mixed number, right? So this is our mixed number, and we have derived our improper fraction by, multiplying this by how many, the denominator here, so in halves. Now if it asked us to do it in quarters, if we just quickly change this, right? This was fourths, and that's 1. We would multiply this by 4 instead. All right, that would give us a totally different. We'd get 20 over 4, and we'd be dealing with 4 and 1, and then you'd get 21 instead, right? And you get 21 over 4. Anyway, that's just a way to understand it. Now we will keep moving on. So now, once we have, we want to keep looking. So so if we are doing this, we can, so this is what we have to do next. So if I give you one like this, it's a bit more tricky, right? 2/5. So we know that, it's not that much more tricky, but instead of having a 1 at the top, we're having a 2 at the top. So we go just 3 times 5, right? Because we're making the three holes are being broken into 5 pieces each. So that would give us how many fifths? This is for making fifths, so we'd get 15 over 5, and then we again, right, this is what's left over. So that was just breaking this down into fifths, so into over 5. We don't want to get that number over 5. So that was all the pieces that went into making 3 holes, because right there would be 5 in one hole, 5 in another hole, that would be 10, and then 5 in a third hole, which would be 15. And then we just add this. We go 2 over 5, and that will give us our final thing of 17 over 5, and that's our improper fraction. So we can do this again and again and again, but I think that's good enough for now as we near the end of this one. So writing improper fractions now as mixed numbers. So if we have a number like this, so let's just say we have 10 over 2. So now we have this nice improper fraction. Well, what we can do here, just like how we multiplied wholes, right? When we have a whole, and I want to get that whole into halves, I multiply it by 2. Now, if I have the halves, right? This is 10 halves, and I want to make it a whole. Oh, come on, camera. How long have you been like that? Okay. If I have 10 wholes and I want to get them into halves, what I'm going to do is actually go like this. 10 divided by 2 is equal to 5 halves, right? This is 5 halves. So you see, 10 divided by 2 is equal to 5 halves. And so that's basically how. So there's 5 whole halves in there. That's because if you had look, if you wanted to look at it, right, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and look, see, I have 5. Oh no, sorry, that's not 5 halves. It's 5 holes. My bad. 5 holes. So yeah, you've got 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, and you've converted these, which are halves. So these are all their halves, and they make 5 holes because you take 2 of them to put together. And so how we multiplied to go from holes, right? This was a hole. We multiply to get to halves, which is 10 halves. We can go backwards, right, with division. So we can go from 10 halves, divide by 2, and we get the wholes. And so that's kind of how it works. Multiplication and division are often opposite of each other, or they are opposite of each other. And so you can use, if you multiplied to get the halves, then you can divide to get the wholes. And so I hope you see how that works. Now sometimes, right, we're left with, we get an odd one, right? 7 over 2. So we also want to use division here, right? We want to figure out how many holes are in here. So we just go like this, 7 divided by 2. Now I'm not going to go through the long division here, but that equals 3 remainder 1, right? Because 3 goes into it 2 times, so you get 6, right? And then minus 6, you'd get the 1, and that 1 the 2 can't go back into. So it'd be like 3. Yeah, sorry, 3 up here. But yeah, you get 0.7 divided by 2 is equal to 3 remainder 1. And this remainder, when you get this remainder, when you do your own math, what this is really is saying that there's 3 holes, and then there's also 1/2 left. So, because we're dealing in halves, right? So what this remainder 1 means is that there's an extra piece, and in our case, the pieces are halves. So yeah, there's a extra piece, which is 1/2 in this case. So, and you can see that because you'd basically have, right, so you'd have 1, 2, 3, 4, 5, 6, and then 7 would be this. So right, that'd be three holes. 1, 2, 1, 2, 3, and then 1/2, and that would be your how this one would be converted into a mixed number. So I kind of hope that that sometimes you'll get remainders when you divide, going backwards, back from improper numbers to mixed numbers. And yeah, you just have to know what you are dividing, what parts you're dealing with there. So if you're dealing with fourths, then that remainder will be in fourths or fifths and so forth. Okay, so finally, we just want to compare some mixed numbers and order them. So we know this, that 5, if I say this or that, and ask you which is bigger, you guys are all going to say this one, because, right, there's more equal parts than in this one. Now, if all I do is just say this or actually, how about if I do this? What's up here? Which one's bigger? Well, this one's bigger because there's a hole, right? So it's a whole piece. And what does a whole piece mean? Well, if we did our multiplication, right, we know that it would be 1 broken up into 5 pieces, so times 5 equals 5, right? And then 5, plus the 2, you'd actually be looking at, so sorry, let me just erase that. What you'd actually be looking at is when you add this to the 2/5, so 5/5, and that would be equal to a total of 7/5, right? And so 7/5 is bigger than 4/5. And a lot easier than doing that is that you can simply think that there's a whole number here. So if there's no whole number there, then this one is smaller. Now if I go like this, and these both have whole numbers, right? They both have a 1. There's one whole piece. Now which one's bigger? Well, this one is, because it has a whole piece and almost another whole piece, right? Because there's just one piece away. It has more bigger fraction over here of the pizza pie, I guess. Yeah, and so that's that. And yeah, and the same would be if you put a 2 here, 2/4 and 5ths. Yeah, you'd also have a right. This one would be bigger because you have 2 whole pieces, right? Instead of just one piece. And then the fraction. So you first look at if there's a full number, like a whole number, and then you look at the fraction and compare. So that's how you do it. And then finally, oh, no, that's actually it. And I'm sorry this video went a bit longer than usual. I think hopefully the next one will be a bit shorter. Anyways, I will let you go and hope that you have a great day. Bye-bye for now. Ciao.